Hello friends, Universal Knowledge YouTube channel ಗೆ ಸ್ವಾಗತ. ಬನ್ನಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಶುರು ಮಾಡೋಣ.
Okay, experiment name logic gates using IC. Aim to construct two input NAND and OR and NOT gates using IC 7400. Apparatus digital experiment board, 5-volt power supply, IC breadboard, two logic level switches with LED to check the output. IC 7400 quad, two inputs, positive NAND gates. Next observation. Pin configuration IC 7400, that is we are using the IC. Okay, this is the IC. Okay, this is IC connection. Here is 7400 is our IC. This is we are putting in the breadboard. This symbol is looking like D. This we are kept in left side. Okay, this IC have 14 pins. These one side 7 pins having and another side 7 pins. Okay, these 14 pins showing us the 4 logic gates that convert into 3 pins are one logic gate, another 3 are another logic gate, that last 7th pin is ground, and again 3 pins are another logic gate, another 3 are another logic gate. This 14th one is plus VCC that supplies the positive current. Okay, let's move on to the experiment. Let's make this connection from DC regulated power supply to breadboard. Okay, first we are connecting positive line to the breadboard, and this power comes to the plus VCC. Okay, we are joining to each other. Okay, this is our plus VCC, and from the negative of DC power supply it comes to ground, and ground to the seventh pin, that is interconnect to ground. Okay, this is our plus VCC and ground connection. Okay, look at this. Okay, let's move on to the first experiment. This is we are doing NAND gate first. Okay, there are 2 inputs and 1 output. Okay, let's move on to the experiment. Truth table of NAND gate. Here is 2 input and 1 output, 1 experimental output and 1 theoretical output. Okay, now move on to the experimental output. Let's make the connection of NAND gate. Okay, A we are connecting to the pin number 1. Okay, this is A connected to the pin number 1, and B connected to the pin number 2, and C we are connecting to the output, that is pin number 3. Okay, make sure that those are not interconnected. Okay, this is the LED we are using. Okay, in this left side having the small flag, that is positive, and the big flag having the negative, that is we are using the LED. Okay, let's make the connection. Okay, this A and B, that is pin number 1 and pin number 2 are open circuit, and output of pin number 3 we are connecting to the positive of the LED. Okay, this is the connection is done. Okay, see, let's move on to the experimental setup. Okay, we are switch on the DC power supply main. Okay, we are putting the 5-volt maximum. Okay, this is the LED light. Okay, which is lamping. Okay, if circuit connection is correct, the lamp is blinking. Okay, this is open circuit. Okay, now we are connecting input of A and B, that is 0 and 0. First reading, our first reading is 0 and 0. Okay, we are connecting 0 to the ground of pin number 1, and pin number 2 we are connecting again to the ground. Okay, this is our input 0 and 0, that is the experimental setup. 1, If that is the light is blinking, that means it is 1. Okay, we are connecting next 0 and 1. A is connected to the 0, that is ground, and B is connected to the 1. Okay, again the light will be blinking, that means answer is 1. 0 and 1, experimental reading is 1. Okay, we return that. Again we are connecting 1 and 0, that is third reading. Okay, A is connected to the 1, that is plus VCC, and B is connected to the ground, that is 0. Okay, again the light is blinking. Okay, that means the answer is 1. Okay, next last reading, that is 1 and 1. Okay, let's see. A is connected to the plus VCC, that is pin number 1, and pin number 2, B is connected to the positive VCC. Okay, there is the light will switch off. Okay, that means answer is 0. Okay, we return that 1 1 1 0. Okay, our reading input is this and experimental output is this. Okay, let's move on to the theoretical answer. Inputs, that is 0 and 0, we are manually doing, that is 0 and 0 is again 0. Here we are using answer A into B bar. Okay, we are using bar because of that 0 and 0 0 will convert to the 1. Okay, and second one 0 1, 0 1 is 0. Again we are using that bar because of that it is convert to 0 will convert to 1, 1 will convert to 0. If the answer is 0, there it will convert to 1, and if the answer is 1, it will convert to 0. Okay, we are convert to 1. Next 1 and 0, the answer is 0, we are converting it to 1. Okay, next last reading 1 and 1, it is 1. So if we are there is an answer 1, we are converting it into 0. Okay, last answer is 0. Okay, the answer we done, we are proved it. Okay, let's see experimental answer and theoretical answer. This is experimental answer 1 1 1 0, theoretical answer is 1 1 1 0. Okay, we proved it. The NAND gate is completed. We done NAND gate. Okay, let's move on to the our second gate, that is NOT gate using NAND gate. Okay, this is the NAND gate, NOT gate. Okay, in this only one input and only one output. Okay, in this circuit diagram A and B are short circuit, C is the only one output. Okay, we are taking two inputs 0 and 1. In this experiment only one input and only one output. Okay, let's move on to the connection. Okay, connecting the inputs, that is pin number 1 and pin number 2 is shorted. Okay, this is short. Okay, pin number 3 is going to the positive of the LED. This is the connection. Okay, okay, pin number 1 is one input. Okay, pin number 1 and 2 are shorted each other, and pin number 3, that is C, is output. Okay, that is connected to the positive LED. Let's switch on the main power. We again put the voltage to 5. Okay, let's, this is the first input, that is 0. If the connection is 0, that is to the ground. Okay, light will blinking, that is the answer is 1. We are connecting the input to plus VCC, that is 1. Okay, light will off, that is 0. Okay, this is the experimental reading, that is 1 and 0. Let's move on to the theoretical value. We calculate manually using formula. Here is the theoretical value, that is 0 will convert, 0 is again convert to the 0, that is we are using the A bar, that it will convert to 1. Okay, 1 is convert to 0. that is we are using that bar. Okay, we get experimental value and theoretical value. Okay, we have done NOT gate experiment. Now let's move on AND gate experiment using NAND gate. Okay, here is 2 input and 1 output, that is C. Okay, we are going to take 4 readings 0 0 0 1 1 0 1 1. Okay, let's move on to the circuit. A is open circuit and B is open circuit. Okay, pin number 1 and pin number 2 are open circuit in this design. Okay, pin number 4 and 5 are short. Pin number 4 and 5 are short. 3 is connect. Pin number 3 is connect to 4 or 5. Anywhere it will short the connection. Okay, 6 pin number 6 is connect to positive of the LED. Okay, this is our connection. Okay, let's switch on the DC power supply mains. Okay, we are putting 4 to 5 volt approximate sufficiently. Okay, now we are taking first reading, that is 0 and 0. Okay, pin number 1 is 0 and pin number 2 is 0. Okay, the light is off, that is 0 0 is 0. Okay, next reading is 0 and 1. Okay, pin number 1 is 0, pin number 2 is 1, that is light is off, that is 0 1 is 0. Next third reading 1 0. Okay, pin number 1 is 1, pin number 2 is 0, light is off, that is 1 0 is 0. Next 1 1. Okay, pin number 1 is 1, pin number 2 is 1. Okay, 1 1 is 1, that is light is on. Okay, now we completed experimental value and we move to the theoretical value. We calculate manually using formula y is equals to a into b. Okay, AND gate symbol shows the a and b. Okay, we have calculated theoretically, that is we compare the experimental value and theoretical value 0 0 0 0 0 0 1 1. Okay, we done the AND gate experiment. Let's move on to the OR gate using NAND gate. Okay, here is 2 input A and B and 1 output C. Okay, we are taking 4 readings 0 0 0 1 1 0 1 1. Okay, let's making the connection. We are doing A and B are short. Okay, and 1 2 are short, 4 5 are again short. Okay, this is 4 and 5 are short. We take 1 to short are interconnected. We are taking one open circuit from 1 2 and another open circuit from 4 5. Okay, these two are open circuits. Okay, now 3 is connected to the pin number 3 is connected to the 9, pin number 9. Okay, pin number 3 is connected to the, okay, we count that 8 9, pin number 9. Now pin number 6 is connected to the pin number 10. Okay, this is pin number 6. Okay, this is connected to the pin number 10. Okay, now pin number 8 is connect to positive of the LED. Okay, we are using jumper for whole breadboard. Okay, this wire we are using for jumper. Okay, this is the connection. Okay, let's move on to the experimental reading. Let's switch on the DC power supply mains. Okay, again we are putting 4 to 5 volt sufficiently. Okay, don't put more than 5 volt. Okay, now these pin number 1 and 2 are open circuits. Okay, now we are taking reading inputs of reading 1 0 0. Okay, now this is 0, pin number 1 0, pin 2 is 0. Okay, switch off, there is switch off. 0 0 is 0, switch off means 0. Okay, now 0 1, we are taking 0 1 0, we are taking this to 1. Okay, switch on the light. 0 and 1 is 1. Now taking 1 0. Okay, A is 1, B is 0. Okay, switch is on, that is 0 1 0 is 1. Okay, last reading is 1 1. We are checking the both A and B are 1. Okay, this is A and B are 1 1. Again the light is on, that is 1 1 is 1. Okay, experimental setup is done. The reading is done on the experimental values. Okay, next move on the theoretical value. Okay, this is the theoretical values. We compare the experimental and theoretical values both. Okay, here the inputs are 0 0. Experimental reading is 0. Okay, answer is 0. 0 1 is 1, 1 0 is 1, 1 1 is 1. Okay, theoretical value we calculate manually using formula y is equals to a plus b. We done OR gate, we compare the 0 0 1 1 1 1 1 1. Okay, we done the OR gate, we done logic gates using IC 7400.
ಹೊಸದಾಗಿ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ನ ಶುರು ಮಾಡಿದ್ದೀವಿ. ದಯವಿಟ್ಟು ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ನಿಮ್ಮ ಅನಿಸಿಕೆಯನ್ನು ಕಮೆಂಟ್ ಮೂಲಕ ತಿಳಿಸಿ.